Okay, Coroneos 100 integrals, number 19. All right, so if we look at this question and comparing to the previous two questions, they look really, really similar. The only difference, as you can see, is inside the square root. Previous question was a² minus x², and this time it is x² minus a². And for the previous one, you're going to substitute by letting x equals to a sine theta. But this time, if you think about this, if we let a equal to a sine theta, and if we square it, we end up with a square bracket sine square theta minus 1. And that creates a problem because we end up with minus cosine square theta here. So with this one here, we can't really square root because since we have a minus inside the square root, if you place a square root on the top, it's just not going to work. So with a question like this, you just have to think about the other, trig substitution. The one we're going to use this time is the Pythagorean identity in terms of sect. So we're going to think about sect square minus 1 is equal to tangent square theta. So if you think about this now, that sect square theta minus 1 is going to be something that's x² minus a². Okay, so what we need to do is think about what substitution we need now. All right, so we need to let x equals to a sect theta. Okay, therefore dx is equal to, if we differentiate it, okay, the derivative of sect theta is, as you can see, is sect theta, tan theta. So that becomes a sect theta tangent theta, d theta. All right, so now we can just do the substitution. The dx, again, is replaced by everything here. So let's just copy everything down. All right, the numerator becomes a sect theta tangent theta. And let's write down the d theta towards the end. All right, over x. X is equal to a sect theta. And then now put everything to the square root. That gives you a square sect square theta minus a². Okay, now before we simplify what's inside the square root, let's cancel the a and a, sect theta with sect theta. So you end up with a really simple fraction. So you've got tangent theta over square root. Let's take out or factorize the a² out. You get sect square minus 1, d theta. All right, let's remove a outside the square root, and it becomes 1 over a. And then if you look at what's inside now, that becomes a square root of tangent square theta, d theta. All right, which means after you've, take the tangent theta outside, you end up with tangent theta over tangent theta, which this becomes a really easy integral, which is 1. And we know to, in order for you to integrate 1, and the answer is just the variable, which in this case is just a theta plus c. All right, again, as usual, we need to replace the theta, by x. So we know x is equal to a sect theta. So therefore, theta is equal to sect inverse x on a. So now, if we substitute all of these, back into the theta here, we should be able to get our answer. So that gives us 1 over a bracket sect inverse x over a plus c. Of course, you can leave the answer like this, and that's how you integrate this question here. All right, again, the harder part with this question is you need to realize what trig substitution that you need. All right, so basically what you need to look at it is look at what's inside the square root, and usually the case is if you have a² minus x², then the substitution you need is x equals to either a sine theta or a cosine theta. If you have like a² plus x², then in this case, you're going to let x equals to a tangent theta, or you can say a cotangent theta. That's going to work. But if you have the reverse process, like an x² minus a², then the substitution will be let x equals to a sect theta, or you can do a cosect theta. But I still prefer the first one, and just make sure that it's easier, so you don't have to introduce negative after you differentiate it. Okay, thanks for watching. That's 100 integrals number 19.